Hi, so I have this interesting exponent equation on the board. We have 8 to the m plus 8 to the n equals 4160. And the first thing I want to do is get a prime factorization of the number on the right. I've already worked that out, and it's actually going to be 2 to the 6 times 5 times 13, and that we can just rewrite this piece as 65. Manipulating the left side of the equation, let's factor out an 8 to the n, and that's going to factor like 8 to the n times 8 to the m minus n plus 1 equals 2 to the 6 times 65. Just get rid of that so it's not confusing. Then looking at what we have here now, we have on the left side, we have the product of two numbers, and this first number has to be even because you have a even number 8 multiplied multiple times. It has to be even. And then this number is an even number plus 1, which has to be odd. So we're looking for some kind of product of an even number and an odd number. Because there's multiple factors on the left side, we could split this different ways, right? We could, it doesn't have to be split just, this is split right now as 64 times 65, but we could split it any number of ways because you could break up this 2 to the 6. So this could also be written as, say, times 2 to the 3 times 65. But you'll notice the problem there is then this is an even and this is an even. And so it turns out, however we split this 2 to the 6 up, if we mix a two in with the odd number on the right, then it's always going to be even. So we could split this number up any number of ways. There's quite a few different combinations, but I think what you'll find is there's only one way to split them so that we have an even times an odd. This is the only way, and I'll show that. We could split up this 2 to the 6 different ways. Let's say we split it like 2 to the 6 times 2 to the 4th times 65, but now we have an even and an even. And however many 2's we decide to pull out of it, right, we could do this and just use 1 2, and even times any number is always even. So by pulling a 2 out, we always end up with 2 evens. Then, now there is one other combination that we could try, because we could actually split up the 65. So we could do this two ways. We could split this, we could have this number times 13, okay, because that's an even, and that's an odd. And then the other way we could split it is bring the 13 over here, and the 5 over here, and then this is still even, and this is odd. So what we'll do is we'll consider that as a possibility as well. So we have this first case, 64 times 65, and we have these other two cases. But let's look at these down at the bottom first. So let's look at, like, okay, if we had over here 2 to the 6 to the 5th, and this is 13, we also need this number here, it's not just to be even, but also to be a power of 8. And if it's a power of 8, that means it only contains 8s. And really 8 is 2 cubed. So this number can only have 2's. And so what that'll do, that'll eliminate this possibility and this possibility, because we want only 2's in this even number. So then we're left with this last case. Let's check this. 64 times 65. We can confirm though, actually 64 is 8 squared. And then so that just leaves us with, we need 8 to the m minus n plus 1 equal to 65. But we can subtract a 1 from both sides and get 8 to the m minus n equals 64. But then that 8 squared is 64, so then we're just saying that m minus n equals 2. We already determined up here that n equals 2. So that means we're saying m minus 2 equals 2, so therefore m equals 4. So that's going to be our answer. We're just going to have m equals 4 and n equals 2. we could switch them, but it doesn't matter because the order is not important here. But let's just confirm that that works. So we're saying 8 to the 4th plus 8 squared. That's going to be 8 to the 4th is 4096, and 8 squared is 64. And so if you add that up, yes, you get 4160.